Okay, let's start modeling with exponential functions. In example 1 says the population growth of a colony of cells is growing so that it triples every hour. Suppose the current population is 10 cells. How many cells will be present after 4 hours? First, we're going to define the variables that we're going to use in our equation. So always look at the question and what it's asking you to determine. So we're asked to determine the number of cells. So that's what y is going to represent. So we're going to first write a let statement stating that y represents the number of cells. And then if you look back here, it says the number of cells grows so that it triples every hour. Okay, so the growth occurs every hour. So that means that the number of cells depends on the number of hours they'll go by. So that's what x is going to represent. Okay, now we're going to write the equation by subbing in values for a and b here. A represents the initial amount that we're starting with. So the initial amount, or the initial number of cells we're starting with, is 10. B represents the growth factor. Okay, it's what we're multiplying by each time. So if we're starting with 10 cells, we're going to be multiplying by 3 each time since the number of cells triples. So we put 3 in for B. And this is the equation that models the scenario. Now to figure out how many cells are going to be present after 4 hours, we simply sub in 4 for x because it represents the number of hours. So y equals 10 times 3 to the exponent of 4. You can use your calculator to evaluate this, or you can evaluate it in your head following the order of operations. So we have to do exponents first. 3 to the exponent of 4 is 81. And then we do the multiplication by 10 to give us 810. And then our therefore statement would be, therefore, 810 cells will be present after 4 hours. Okay, the next example, it says the hydrogen isotope tritium is radioactive with a half-life of 12.5 years. A sample contains 35.2 units of radioactive tritium. What amount would remain after 25 years? So let's go over some of the terms in here. The word isotope, it's simply similar to the element tritium, but it has more neutrons in it. The important part is that it's radioactive, so it has a half-life of 12.5 years. And half-life means that it takes this amount of time, of 12.5 years, for the mass to be reduced by 1/2. Okay, so let me give you an example of some other substance that has a half-life of 5 days. And we're going to start with 100 grams of this substance, whatever it is. So we have number of days and mass. So if 0 days go by, we have 100 grams. If 5 days go by, this mass of 100 grams will be cut in half, and we would only be left with 50 grams of the substance. If another 5 days go by, we'll be left with half of 50 or 25, and so on. So half-life is the time it takes for radioactive substance to be cut in half or reduced by half. Okay? So looking back at this problem, we have to define a variables that says what amount would remain after 25 years. So the question is asking us to find the amount of tritium. So that's what y is going to represent. Let y represent the amount of tritium. And the amount that remains that we're going to have left over depends on how many times the mass is going to be cut in half or reduced by half. Okay, so that's what X is gonna represent. Let X represent the number of times the amount is cut in half, or a simpler way to put it is the number of half-lives that go by, or the number of 12.5 year periods that go by. Okay, so now we're going to model it with the equation. The initial amount that we're starting with is 35.2, so that we're going to sub it in for A. For B, what are we multiplying by when we're reducing something by half? We're multiplying it by half. 100 times a half is 50. 50 times 1/2 is 25. So this is going to be our decay factor. Decay because we're going to be decreasing the amount of the substance. And this is our equation that models this scenario. Now we're going to use it to determine how much of the substance will remain after 25 years. So we have to determine what number we're going to sub in for X, if X represents the number of half-lives. So you have to ask yourself, how many half-lives or 12.5 year periods are there in 25 years? And the answer is 2. So if I take 35.2, actually, and multiply it by 1/4, because 1/2 squared is 1/4, I would get an answer of 8.8. Therefore, 8.8 units of the radioactive substance tritium will remain after 25 years.